word, but I was I was enraptured. Okay, so yeah, I'm Sam, the co-founder and CTO at OSO. And I'm going to talk about authorization, which is one of the main things we're solving here at OSO. So I'm just going to give people a quick outline of what is authentication and authorization, how it relates to your application. I'm going to talk through some very common patterns around roles and do a little live demo for this in SQLAlchemy and OSO. And I'm going to keep trying to go through things reasonably fast. Okay, so authentication is this process of identifying who you are. So, you go to GitHub, for example, you log in with the username and password, and you sign in as, in my case, Samsco89. This is authentication. GitHub now knows I'm Sam. And the next question is, what can Sam do? And so this is authorization, right? So suppose I try and visit these two URLs, one for the OSO org teams, one for SQLAlchemy teams. I see these two different pages. And basically what's happening here is that GitHub has decided, oh, Samsco89, you're a member of the OSO organization. You can see the teams. But as it says here at the bottom, I'm not a member of any teams in the SQLAlchemy organization, so it's not allowed. All right, this process here is authorization, and this is what I'm going to be talking about today. Now, authorization is kind of this somewhat vague, unstructured problem, who can do what in your application. And it's very easy to end up with code that looks something like this, where you have a sort of ton of if-else statements, you're checking a bunch of different conditions, because often this is what permissions come down to. It's like who can do what, and you define this by checking the various properties. So what can we do better than this? Like how can we make our application structured nicer so it's easier to maintain, update, change, things like that? So roles is this very, very common approach to this. Now, what roles does is it takes your setup like this. So suppose you have a bunch of users, you have a bunch of resources, things they're trying to access, and it helps you break this problem down. But I should say you often see this abbreviated as RBAC, which stands for role-based access control. Again, so what roles do is they take this problem and they basically say, all right, well, most of these users, maybe they fall into this bucket. We call them members, and there are only a few people who are, privileged users. We'll call them admins. And now instead of having to define what everybody can do in my app, I just need to define what these two people can do. Members can read and write, and admins can additionally delete. Kind of simple as that. And again, like looking at this in like a realistic example, here is a kind of a slice from GitLab's permission system. And so you see along the top here, they have 5 different roles, from the guest to developer to owner. And there's like this table of all the things they can do, right? So this is a pretty decent role system. And GitLab is this huge application. There's a ton of stuff you can do, from maintaining source code all the way down to like managing Kubernetes and deployment, stuff like that. So there's a lot of things you can do in it, but they've managed to reduce it to effectively these like 5 different roles. And the nice thing about these roles is they kind of give you this intuitive sense of what you should be able to do. Right? Like you wouldn't expect that a guest to your organization could come and start deleting projects or things like that. Whereas the developer, can probably manage the code, they can make edits, things like that. Owners can do everything. Okay, so this is like a nice example of roles done quite well because there's like a relatively small number of them, and they kind of relate to intuitive concepts. So what I want to talk about around OSO is how it kind of helps you to build this kind of a system. So OSO is an open source authorization system, and it's designed specifically for developers building security into their apps. The kind of core of OSO is a library, and this is a library for making these authorization decisions. So deciding who can do what in your app and enforcing that and adding this to your application. And it's available through standard package managers. So in the case of Python, pip install OSO. But it's also available for a number of different languages. The core of OSO is actually written in Rust, and we make it available to multiple different languages. So Node, Java, Ruby, Python, Go, Rust. The second piece is we made OSO sort of batteries included. And what I mean by that is we've kind of given you out of the box functionality to manage things like roles in your application. And that's what I'm going to be showing you in the demo, is how we've enabled this in SQLAlchemy to allow you to do like a very rich like roles-based access control system in your app with SQLAlchemy and OSO. And the final piece of OSO is effectively how you configure it. And you do this through the policy language called Polar. And it looks like this at the top. So this allows you to express who can do what in your app in terms of, and by writing these rules. So this rule here, for example, says that a user is allowed to read an organization if the user is in the organization members. And this policy here, it's written in the Polar language, which is declarative policy language, but it's expressed over your application objects. So when I actually call this at the bottom in the Python library, for example, I call the also is allowed function, and I pass in my user object, my organization object from my application data. So this policy at the top here is expressed over attributes or methods or types, things like that from the application. So for those of you who are familiar with SQLAlchemy, it's this large, amazing toolkit for handling all kinds of SQL inside your application. So you can managing everything from writing SQL queries and expressions. It's got like an ORM model, so you can use Python classes to represent your data models, migration tools, and kind of on and on. It's kind of this entire toolkit for everything SQL in your app. Also kind of wants to be the same for authorization. And so the pieces I've spoken to you about today is sort of just the starting point. And kind of in this way, these two provide this like really great match together, where they sort of are both giving you a lot of this out of the box kind of experience and things you need to think about for how to do SQL authorization. And we'll see together how those kind of pair up nicely. Okay, cool. So I'm going to give a little demo of the SQLAlchemy OSO integration. What I'm going to start with, I have a very, very simple GitHub API built with a combination of Flask and SQLAlchemy, which I'll walk through. We're going to start off just by adding some simple authorization with OSO. So just want to kind of get the basics in, and then show you what it would look like using our built-in stuff for roles, so we can kind of create something similar to what I was speaking about earlier. Okay, so here is my application. Let me make this a bit bigger for you all. Here's my data models. So this is where I'm using the SQLAlchemy data models to define my data sets. So this is very, very straightforward. I have a user class, has an email address, for example. I have organizations. I have repositories, right? So this is my GitHub, very simple GitHub data model. And repositories can belong to an organization, for example. Then in my routes.py files, this is where I'm, my Flask API endpoints I'm using. I have some simple routes to allow me to do things like list all the repositories in an organization. So for example, if I go and get so I'm going to hit the API using curl. If I curl this API as the user pool at Beatles.com and get the repos for organization 1, you can see the organization has one repo called Abbey Road, whereas organization 2 has one repo called Paperwork. Okay, so right now, every user can do everything. So what if I actually wanted to restrict what Paul at the Beatles was allowed to see and say that he could only actually see repositories from organization 1? So what I might want to do is add in some authorization here in my repos index to check that the user can actually read this organization. So first of all, I'm just going to get the current app helper from Flask. Allows me to get application state. And I'm going to get the OSO object off of my application state. So where's this coming from? What is this? So the way I initialize OSO is in my Flask initialization. You just see I have a method on my app that I'm going to call on startup, which is just going to create a new OSO instance and do some relevant things like load my policy files in. As I said, that's how I configure my app. My authorization is through policies. And finally, I'm just going to add OSO onto the application state. Okay, so that's where that's coming from. I can now get my OSO instance and do authorization. So I'm going to use the Flask OSO helper method authorize, which will take in the organization. It's automatically going to populate the current user, but I'm going to say the action I want to check is a read action. Okay, so once I've added this line, I'm now doing authorization as part of this API endpoint. If I now go and try and access an organization, I'm getting 403 forbiddens. Nothing is allowed anymore because basically, once I configure OSO, it's denied by default, and my policy is currently completely empty. I have no policies. I haven't allowed anyone to do anything, so everything is not allowed. Let's change that. Let's allow everything. Let's allow every user to do every action, to every resource. And I can do that by writing it this way. These are basically my inputs, my input variables. And I don't need to add an if statement. I can just say this is always true. So now I've done that. I am now able to access everything again. Okay, so we're making some progress. We have authorization, but we've allowed everything. Let's restrict that a little bit more. So like I said earlier, these inputs are coming straight from the application. So this user is a user. The action we're checking is read, and this is actually an organization. And so we want to say, maybe we just want to say that the user's email address must end with Beatles.com, let's say. And the organization name of organization number 1 is actually the Beatles. There we go. So now we have a policy saying that only users with the Beatles.com email address can read the Beatles organization. So I can still not access organization 2, but I can access organization number 1, which is the Beatles org. So cool. I've got some authorization going on. But clearly, I don't want to have to do this for every single user in my system, every single organization that joins. I want this logic to be like generic over organizations more generally. And so that's where roles come back into the picture. I basically want to express the fact that users can have a relationship with organizations, and that relationship is effectively their role. So let me reset this. Okay, so I just checked out a new branch which has my roles implementation, and I'm actually going to reset that so I can show you the diff. There we go. Okay, so you can see the changes I've made. Right here, I might need to make that a little bit smaller. So in my initialization page, I'm just importing this new built-in roles functionality and enabling that on the OSO instance. So that's all that happens. And really the magic that's happening here is I'm importing this resource role class helper from the SQLAlchemy OSO roles package. And what that's going to give me is give me this sort of helper method that allows me to define a mixin to create a roles relationship between users and organizations. So here we can see it. Let me hide this. So here we see we're creating the mixin by calling this helper method from OSO, giving it in the user class, the organization class, and the list of roles we want to create on that, between those two things. And now I have this mixin, I basically can create a new SQLAlchemy model. So this is creating a new database model, but basically pre-filling a lot of information from this OSO helper mixin. And now that this is in place, I now have a data model connecting users and organizations. And actually, there's a bunch of helper policies now already added to my app. So I can now start doing authorization directly over users that have roles in my app. So suppose I added some data just like this to say, for example, that John is an owner of the Beatles org. Then in my policy might look something like this. And let's go back to the regular screen. Here we go. So instead of writing my allow rules like I did before, I can now write these role allows, which really have the same purpose, but is effectively handling all the the database lookup. Is a person in a particular role or not? Like, does this exist in the database and those kinds of things? I can just focus on writing permissions in my system. So like this one says that if you have any role inside an organization, then you have read access to that organization. So in my root now, in my repos index root, you can see that I've updated the action to list repos. So I'm going to check whether the current user is allowed to list repos for this organization. And if I now come back, okay, cool. So you can see Paul is now still able to list repos from organization 1 and not from organization 2. But whereas before we'd kind of like hard coded the Beatles.com and the org1 thing, this is now true over all users and all members who have roles. So for example, I have Sally at monsters.com who cannot read organization 1, but can indeed read organization number 2 because of the role they have. And yeah, so this is really all that we need to write in here is just some simple policies about what can roles do. Everything else is taken care of in the database models. And I think the really nice thing about this is just how few lines of code we needed to get that role model set up. This is now extremely extensible. It can support everything from like inheritance patterns, hierarchies. It can do things like you could even have a role for a repository if you have the role in the parent organization, things like this. And with the OSO SQLAlchemy integration, this is actually all enforced at the database layer itself. So this is incredibly efficient because it's actually all happening just over the database and not like in the Python code. Okay, so those are the main things I wanted to cover. This was a pretty kind of quick intro to OSO and the SQLAlchemy stuff in particular. We have a lot more information available on our website, on our doc site, or you can come speak to us directly, for example, in our Slack channel we have for the open source community, or see things on our GitHub. And specifically, if this example is interesting, I'd recommend on the docs page, we actually have that SQLAlchemy example as like a tutorial. Okay, thank you very much for listening.
Thank you so much. That was super interesting. And thanks for sharing the links to where to reach you and get some more information. On my side, I didn't receive any questions for your talk for now. So thanks.
No worries.
Hey, thank you, Sam, for your talk. I don't know. I don't have a lot of experience with authorization and all of that thing. But can you give us a bit the comparison about also and maybe the other system that already exists? Why also is like more cool? Or
So I think the thing that I think really sets OSO apart is that we're sort of going for the we're trying to kind of have the best of both worlds in that it is very easy to do the sort of simple things, and you know, roles can get complex, but like when you start out and you just need, say, a user and an admin, you have two roles, maybe you just hard code them, it's fine. It can start out easy, but like over time it gets hard. And so what we're really trying to do is make the easy stuff easy by providing that out of the box, 2 lines of code, you're good to go, you have roles. But because it's, you know, backed by this policy language, the policy language itself is like very powerful, and can, you know, be used for more things than just authorization, for example. This actually means it's like very extensible. So as your requirements change, if you have some weird use case that's not quite a role, it's like somewhere between the two, it's fine. The policy language will let you write those. And I think like a lot of frameworks, they maybe do the simple stuff very well, but they don't let you extend, and then you get into this like very hard situation where you're trying to like fight against the system.
Thank you, Sam. I actually got 2 questions as you were answering this one.
Aha.
So the first one is, how does it incorporate with JWT containing scopes? And the second one is, how does it work with Fast API?
Okay, so on the one about JWTs, so for people who aren't familiar with JWTs, these are sort of authentication credentials. So you get like a cryptographic token that maybe can include extra information. For example, a scope is like a typical one that, you know, the GitHub API contains, for example. So you might create a API key that's given a specific scope that says, you know, this token allows the holder to read repositories, that kind of thing. So how that looks in OSO is you would you basically use it as additional information on the input user type. So maybe in this case, you maybe need to look at a combination of 2 things. So the user might be the person who originally created the API token, but maybe the token itself is kind of limited to only fewer things, right? So I've created an API token for GitHub, so it can do things as SAM-89, but I don't want it to do everything. I want it to just be able to read repositories, so it has that scope. So then your policy can contain both. Like, what can SAM do? What can the token do? Make sure that both are applicable. So hopefully that answered that question. On Fast API, it works pretty well with Fast API. I think there's like a lot, because Fast API has like a very strong preference towards strong typing. I think that works very well with the kind of types that you can use inside the Polar policy. And we do have someone who actually from our community who wrote a Fast API example app with OSO, and it fit really nicely. It was a good combination.
Good to know.
Don't have the link to hand, but it's, if you could either join our Slack or email me, and I can share it with you.
Okay.
Okay. Yeah.
Awesome. That's all.
Okay. Thank you, Isabel, for the question, and Sam, thank you, Sam. Yeah, I think we